Happy New Year, fellow Ops Monkeys. Hope your 2021 is off to a great start, and you are continuing in your tracks to increasing your knowledge. Today we're going to take a look at a familiar request in the DevOps world. Your stakeholder, whether it be a developer, a TPM, your boss, etc., comes to you with this question. Hey, Ops Monkey, my Kubernetes app needs an S3 bucket to store objects in, and the ability to access that bucket without storing any credentials in the pod of our app. With that in mind, let's introduce IRSA, or IAM roles for service accounts, and how to use them to get your pod's access to the AWS resources without storing your credentials in a config map, a secret, or even in the pods themselves. If we take a look at what AWS has to say about the subject, they talk about turning the pods into first-class citizens in IAM rather than intercepting the request to the EC2 metadata API to perform a call to the STS API to retrieve temporary credentials. They made changes in the AWS identity APIs to recognize Kubernetes pods. What does this mean? Basically, by combining OpenID Connect, or OIDC, you'll see that a lot, identity provider and Kubernetes service account annotations, you can now use IAM roles at the pod level. Basically, guys, if you want to drill down into this, you can go read the page about what this does. But in the end, you can use IAM policies direct with service accounts through OIDC to authorize your pods to access AWS resources. You may be familiar with using IAM roles and policies to attach to your EC2 instance in order to provide access to AWS resources. This is the same type thought, but instead of attaching roles to your instances or your nodes, you are using service accounts inside Kubernetes to allow pods to access those resources. If we move over to identify the needs, we're going to need to know where the repository is that holds the app. The repository with the infrastructure as code. We're going to need Terraform installed. For the sakes of this demo, we're going to have a pre-set up VPC, subnets, internet gateways, and a pre-set up EKS cluster. We're going to need to make sure IRSA is enabled in the cluster. You basically need to have an OIDC endpoint enabled. We're going to need to create an S3 bucket. We're going to need to create an IAM policy allowing access to that bucket. We're going to need to create a Kubernetes service account that ties to that IAM policy. We're going to need to deploy the app out and test for access to the bucket using IRSA. There's a couple of things that are involved with this. IRSA involves assuming roles and policies across the board. We'll walk through all of those steps next. Basic setup of your environment. You're going to need an AWS account. The repo is actually set up in a multi-account setup, as I'll be using it for other demos. You're going to need an AWS IAM user with credentials to run the Terraform code against this account. Terraform installed on your machine. For the demo, we're going to be using Terraform 0.14.3. We're going to have a VPC EKS Cluster set up and access already set up to that. And we're going to dive into creating the S3 bucket, creating the policies that we need, and then creating the Kubernetes resources that are needed inside the cluster to use that. And we'll go ahead and deploy an app with that service account and show you how that works. Alright, hope you guys follow along, and let's jump into it. Here we are looking at my demo repository that has our pre-existing VPC, subnets, gateways, security groups, and more. It also has a pre-existing EKS cluster with a node group made up of spot instances basically ready for us to go. Let's take a quick look at the structure of the repo and mention some of the reasons why you might set things up in this fashion. First up here, we have our example Kubernetes app, which is just a Ubuntu Docker container that will sit there running for us. If we look below that, we then have an environment directory with several different environments below it. This directory holds different back-end information per environment, and if you take a look, the only thing that is in here is the key to where the path for the Terraform state will be held inside the Terraform S3 bucket. And the only thing that's different is the environment. Per environment, why? Well, at most places should have multiple environments, such as test and dev, staging, and production environments. This keeps segregation and data layers separate from each other. No chance of big risk of accidentally applying something in production. This also allows you to promote your infrastructure as code in a similar pattern to releasing software through environments. That way you can test it, push it up through the environments, get it validated before you push it out to production. Which is always a good way to set this up. This also allows you to use the same exact code in between all the environments. Repo also assumes different IAM roles per account. These have been preset up per account with permission needed to apply Terraform. My local credentials also have the ability to assume those same roles. If we jump over to the source directory, we can see the already previously created VPC, the previously created EKS cluster, and those are all just sitting in here. And one thing to note is I am pulling from the Terraform registry for modules. So if we take a quick look at the VPC, we can see that I'm pulling from the public Terraform registry for this module. That means I didn't have to set up any of this work for creating all the subnets, creating the NAT gateways, creating the internet gateways. This module does it all for me, and will do it for you if you go use it. Same thing if we take a look at the EKS, pulling from the public registry for the module, basically setting up an EKS cluster for me, enabling the different configurations that I want. And a big thing to note here is this enable IRSA is currently set to false. We will need to set that to true for what we're doing. Also, if we jump over to the variables real quick, you will see everything, or not everything, but a lot of these variables have been mapped out per environment. So test, staging, prod, test, staging, prod, test, staging, prod. This is what allows you to basically set different environment variables per environment. Like for an example, say the public subnets test and staging are only using 3, but production is actually going to use 5 or 6 depending on what region you're in and how many availability zones that you're at. If we scroll down to say the EKS cluster settings, you can also see different settings for the auto scaling groups as far as min and max sizes, the different types of disk sizes, the instant types that we're using per different environment, all just mapped out here in a variables file. If we go to the terminal, you can also see I have command line access set up with kubectl and ready to go for the EKS cluster. So if I type k get nodes, we'll see that we've got 2 nodes ready to go. If we do k get pods dash and default, we'll see that there is nothing running in the default namespace. So we have a clean VPC and an EKS cluster to work with. Let's go ahead and run a Terraform init and a Terraform plan just to make sure that our Terraform code is all good. So Terraform init, we're going to feed it the backend config equals directory of env test backend.tfrs. This allows us to feed that backend configuration to Terraform so it knows where the state is located and which one to use per environment. And then the source code that we're aiming at. And it's pulling any of the providers that we have declared and setting up the Terraform workspace for us. And we can see it's successfully initialized. Let's go ahead and clear that out and do a plan. Terraform plan, and we're going to pass it the var env equals test and the source code directory. This is going to read the state and look at AWS just to make sure that there is no changes or differences in the code that we've got here. We'll let this run. Hopefully it'll report back with no changes. And there we go, no changes, infrastructure is up to date. Alright, so we've got the clean VPC, we've got the clean EKS cluster, our code is currently clean and all applied out there. Let's go ahead and start to add in a few files that we're going to need. So inside the source directory, we know that we're going to need to add an S3 bucket according to our request, so let's do an s3.tf. We know that we're going to need to create the IRSA links in between the IAM roles, assuming the policies and the Kubernetes service accounts and namespaces. So let's just go ahead and create a file called irsa.tf. Now, we're going to put together a very basic IRSA Terraform module, as this is something that we're going to want to repeat quite a bit, right? One developer might need access to S3, another one might need access to SQS and SNS, another one might need access to create storage somehow. Either way, great example of where you should make a small repeatable Terraform module that you can call that will just continually do the work for you. So let's go back up, and we are actually going to create a new folder, and we are going to call it modules, and we're going to move it out to the root of the directory. Inside modules, we're going to create another new folder, and we're going to call this EKS IRSA. Inside here, we're going to need to create a basic structure for a Terraform module. And remember that Terraform modules, you really want to keep them driven by variables and outputs. So you want to make it so there's nothing really hard-coded unless it's a very specific module. So we're going to start out with, we're going to need to do some IAM work, IAM.tf. We are going to need to do some IRSA work. We are going to need a variables.tf file for all the inputs, and an outputs.tf file for any information we need to output from the module back to our main Terraform. And I'm just going to paste in the code so you guys don't actually have to watch me write out the code, and we'll just go through it. We're going to create a policy document and a data resource that we can call below. This policy document basically allows the actions of assume role with web identity, and then it attaches it to the server's account, the namespace, and the service account, and then adds the principals based off the account ID and the OIDC along with the issuer URL. It's going to create a role that it attaches that policy for. This is the role that the service account is going to actually assume. We're going to add an additional policy, and you can see these are all based off of counts, whether they should be turned on or off. This allows us to pass a policy into the module and attach it to that same role. So we will actually create an S3 policy and pass it into the module. Let's hop over to the IRSA part, is the Kubernetes side of this, where we're going to actually optionally create a namespace. We're going to create the service account that actually ties to this. So let's go ahead and paste that in, and we'll take a look at it. So creating a namespace off of account, just in case we need to create one, or you can pass it to the modules. We're going to use a local that sets the service account either by the var or by the name. And then we're going to create a service account inside that namespace that we either create or we pass to the module, along with the metadata and then the associated role that it gets attached to, and a lifecycle basically to ignore it. Now, all of these have all these vars that we're going to create, so we need to come in here and add all the variables. And you can see there's the variable of namespace, the service account cluster, whether we should create the namespace, whether we should create the service account associated. We should enable IRSA, the policy, the issuer URL, and the associated account ID. These are all the inputs to this module. Now we need to put any outputs that are required that we can send back to Terraform from this module. And there's going to be very few that I can think of that we need. And remember, this is just a really basic module that we're writing just in case we need to repeat this. So you can see we're doing an output of a namespace, the output of the service account, and the output of the associated role that we could use from this. So let's just double check. We've got all of our variables in place. Save it and format the document. Okay, now let's hop over, and the one thing that we do know that we need to create is that S3 bucket that is for the app to hold anything that it wanted to hold, whether it be objects or assets or anything like that. So we're going to come back and start with just creating a very simple S3 bucket. And if we look, we're just naming it as IRSA test bucket. It's got a private ACL on it, and we're adding some tags. Pretty simple. We'll save that. Now over to the IRSA. Now this is where we're going to actually create a policy and then call our module, pass that policy to the module to create the associated roles and the service accounts inside Kubernetes for us. And then we'll do some testing from there. And this is one of those reasons why you want to make modules and make them repeated. In this case, we'll take a look. We're creating an IAM policy document that has the ability to list all of the buckets, and then it also has the ability to do any S3 action within that bucket that we're creating for the IRSA test bucket. Now we're calling the module that we just wrote. It's calling the EKS IRSA module. It's enabling the IRSA policies. We're going to put it in the default namespace, so it does not need to create a new namespace. We're going to call it S3-policy, and we want it to create that service account. We're going to pass the cluster name in. We're going to pass the issuer URL in. We have to do a replace here in Terraform because the output of the OIDC issuer URL includes the HTTPS that we want to remove. So we're just doing a replace, and we're replacing that with nothing. Passing over the account ID that's mapped off the environment, and then passing in the JSON data from this policy document above. So let's go ahead and format the document and save this. And let's go ahead and do a Terraform plan and see if all of our code looks good. And we can see that it's going to add 5, 0 to change, 0 to destroy. Let's take just a quick gander through the plan here. We can see that it's creating the data document that will be read during apply. It's creating the S3 bucket for us. It's creating the S3 policy role. That's the policy. Here's the role. Kind of check out and make sure everything looks like it's filled out correctly. It's doing the policy attachment, and here it's adding the service account called S3 policy to Kubernetes for us. Let's go ahead and deploy our demo app and take a look at it real quick. So if we pull our demo app over, we can see that it's just a deployment with a single replica, no ingress or no service like that. It's just a container that's it's an Ubuntu container that we're calling AWS CLI, and it's just going to sit there and run for us. Right here, you can see this is where you would call the SA to assign to the pods. We're going to actually go ahead and comment this out to prove that the pod has no access before we deploy it. So let's do a K apply -F, And we'll run a dry run, as you always should. Dry run equals client. It says it was created, so it should be valid enough. Let's go ahead and apply it. And we'll do a kget PO. And we can see our AWS CLI pod running inside our Kubernetes cluster. Let's go ahead and get on it. Kexec-it --bin bash. Make sure it's all running. We'll need to install AWS CLI. I probably should have chosen a better container to run, but let's just get this done real quick. Apt-get update. Git install AWS CLI. Okay, now that the AWS CLI is installed, we can do a quick test, AWS S3 LS, and it should deny us, just like that. So we can see that this pod, currently in its state, has no ability to actually list S3 buckets or call that other S3. Let's get out of this. Now let's go ahead and apply that Terraform code, which will create the S3 bucket for us. It will create all the IAM roles and policies and create the service account that's tied to those policies, and we'll go from there. Yes, we wanted to create. We'll give it a minute to create that test bucket for us. We can do an AWS S3 LS from our local machine, and we should see that IRSA test bucket. IRSA test bucket. And let's go ahead and kget PO, make sure it's all still running over there. And let's go ahead and uncomment that service account name in the actual Kubernetes YAML deployment. So service account name S3 policy. And if we do a kget SA, we should be able to see that S3 policy service account, which we do. And if we do a k describe S3 policy, oops, k describe SA S3 policy, you will see that it's in the namespace of default, and it's got the annotation with the role to assume to be able to access that S3. So let's do a k apply -f, and we'll do a dry run. Looks okay, so let's go ahead and apply it. And we'll take a look at this real quick. K describe deployment AWS CLI. Hold this up a little bit. And as it's describing, you can kind of go through here and look at all the specs for it. And you can see right here where it says service account, it's calling the S3 policy. So if we do a kget pods now, we can climb on this pod, kexec-it, and now if we do an AWS S3 LS, we can see that we have access to list out the buckets. And if we do an AWS, let's touch a file, touch, and then let's go ahead and copy it up to that bucket. IRSA test bucket. And let's list it back out. AWS S3 LS S3 IRSA test bucket. And we can see there's the test text file on that S3 bucket. So now we've basically used a little bit of Terraform to involve AWS IAM policies, assume roles with web identity through OIDC, creating a service account with inside Kubernetes and attaching that to a pod. That service account has the ability to use OIDC to assume that S3 role that we applied to this. If you want to get really in depth with the way that OIDC works and all of this actually communicates, I obviously recommend that you go read AWS's resources and guides that are put on this, but this was just a quick demo. Hope you guys learned something. It's actually pretty easy to use IRSA to assign IAM policies to pods, and that's all you basically have to remember that it's good for. If you have any questions, hit me up. Otherwise, I hope you have a great day, and we'll see you guys next time.